Good morning, everyone. I welcome you all to day 3 session of this certificate program in herbal technology. Myself, Sukumari Vallinayagam. As per the plan, today is the third day of Unit 2 session. In this session, we are going to discuss about the processing of the herbal plants. Yesterday, we discussed how we can collect, how we can cultivate. Today we are going to discuss about the how we need to process, what are the steps in the processing, and how can we identify the plant with morphological and histological studies. Okay, processing. In the processing, we have a different step. Yesterday we discussed refrigeration, drying, frozen, many things. As per the point, today we are elaborately discussing about refrigeration, drying, and all. Refrigeration, we all know about it. There is a normal process. We need to keep the herbal plants or any aromatic plants in a fresh condition. We need to maintain the refrigeration. Refrigeration temperature is 2 to 7 degrees Celsius. What kind of plants we can frozen? Okay, there are two types of thing for used. We are processing with the refrigeration process, that is the fresh herbs. Another one is edible flowers. Fresh herbs is nothing but basil. It's normal daily vegetables, daily routine stuffs. Okay, that's and sages, s- rosemary, mint. The smell, which plants will rising smell is main thing we need to maintain in a frozen refrigeration condition. This is the refrigeration. 2 to 7 degrees Celsius is not a deep cool condition. It's a light cool condition. Fresh herbs, which are all know, every mint, coriander, they spread some small amount, small smell. That is indicating, so there are some amount of flavonoids which are present in that particular plant. Many plant flavonoids are helping to improve your antioxidant property, and they are having an anti-cancer property. So, if you are handling the herb like a mint, simum, or coriander, we need to keep it in a refrigeration condition. Otherwise, we have to use the plant or fresh herb in immediately we have to use. Otherwise, we need to keep it. Every herbs are can be, we can kept it in a below 0 degree Celsius. But the one thing is, some plant flavonoids may be degradable at below 0 degree Celsius. So plants which uh, express smells, they are they are producing the flavors, the fragrance, means we won't keep that in a 0 degree Celsius. We have to make that in particular degree Celsius, like 0 degree, above 0 degree, 2 to 4 degree Celsius. Okay. How what kind of plants we can kept in the below 0 degree Celsius? That is garlic, coriander, basil, mint. These are all the things also favorable for below 0 degree Celsius. For the herbal purpose, for the herbal medicinal purpose, we need to store it properly with the plastic containers, or we need to have specific plastics packaging material. For below 0 degree, we are not able to keep that material in a normal plastic material. We need to design a specific material for below 0 degree Celsius. 0 degree Celsius. Okay, next thing is the drying process. Regular process. This drying is very important because in the drying process, apart from normal drying, this drying process is a natural drying. It may be in a shadow, it may be in a sunlight. Okay, what that sunlight means, stems, roots, that materials can be dried in a sunlight. But leaves, flowers, we are not allowed to drying in a sunlight because that having some flavonoids, alkaloids material. We have to maintain that in a drying. For industrial techniques, they are using many different kind of drying method. Drying is nothing but dehydration. Okay, what kind of dehydrations are they are using means drying forced by the convection. Okay, convection, lyophilization, dehydration, and microwave irradiation. These are the techniques which are used for the industrial purpose, because the for industrial purpose shadow drying will take some time. Okay, they are having a bulk material or not able to maintain drying in a large quantity of herbs, so they are using drying forced by the convection, lyophilization, osmotic dehydration, and microwave irradiation. And the factors, some of the factors are need to be Celsius, not going above, because flavonoids, some flavonoids are easily evaporated at above 40 degrees Celsius. So we are not allowed to drying more than the 40 degrees Celsius. The drying time is very very important. As I mentioned, we are following the shadow drying means that will take around 1 week, 3 day to 1 week. So this drying time is it's a little bit higher. Okay, next in the view of the drying, the drying process. Post day, after the drying we need to separate the after the drying only we can found any dust, any other plants are mixed in that particular crude raw material. We have to separate the dust another material, and after that, after drying we have to separate the parts of plants. We have to separate the leaves, separate the stem, separate the root, everything. That separation process is very important, and in the separation process we can easily understand which is a very needed one, which is not needed one. So this process is very important. And in this post drying after the separation of this parts, we have to homogenize the particular material. Homogenize is the, at the homo means it's the same. Okay, we have to ground or crush the plant material, and we have to separate separate the material based on their size. For example, if you have a plant material with a 350 micron or 750 micron means that is during the extraction process we get some little amount of alkaline. But if you reducing to 150 micron, okay, 150 micron, you can get the more amount of alkaloids during the extraction process. If you are reducing the micron size, the plant material size, you can get more phytoconstituents, any products. If you are reducing the materials, the raw material size, you can get more product. And we have to cut with the different cut powder, plant, everything. Processes post drying. After that, distillation is nothing but the removal of the water process. After for removing water we have to boil it. Distillation, the removal of water, nothing but water, removal of the solvent, cooling and separation vessels. Okay, this is the extraction process, and the extraction is to helps to separate the phytoconstituents. The main thing is phytoconstituents, or we can extract the phytoconstituents, we can extract the sugar, we can extract the protein. Many steps process. In the extraction process we have fluid extraction, soft extraction, dried extraction. This fluid extraction process we are going to use ethanol. Okay, this ethanol for various plants we can select various concentration of ethanol. with the water. This is it's normal extraction. This is a fluid extraction because during the extraction we have to focus on the polar solvent, non-polar solvent, and mid-polar solvent. If you want to collect the fragrant material, volatile material, you have to going with the ethanol or hexane. Hexane is a non-polar material. Ethanol is mid-polar material. So you can easily separate with that polar, non-polar materials are easily mingled with each other, and we can eluted easily. Selection is very important. We can refer separate the solvents based on their polarity: non-polar, polar, mid-polar. And soft extraction is a semi-solidation. This is obtained by the evaporation and partial evaporation process. And dried extraction is extracts. It's a solid preparation. This is solid preparation. It's helpful for this. It's take long time to reduce the water content in that. The more than 5%, it's not allowed in the material. We will need to remove the whole content, water or solvent in the plant. This is the dried extract, or like dried extract alone. Okay. But then the packaging is very important process. After all the step, this packaging process is introducing the raw material, semi-finished product, or final product. Anything we can packing. That packing material should be clean, should be standard, with maintain the aeration, everything. Some phytochemicals are light sensitive, some phytochemicals are easily absorb moisture. So that packing material should be designed the raw material. The label, okay, after the packing we have to label the particular box. We can label it in a Latin name, popular, what is the local name, popular name, and part, which part we are packed in that particular box. And presentation is nothing but it's a powder or a solid or liquid form. And batch number, okay, date with the batch, zone, which area we are transported, and expiration date, and a supplier name, wage. Okay, after the packing we need to store it in a particular place. That storing temperature, why we need to store it means that is a conservation or production, everything. We need to protect against light, low temperature, the low humidity, low temperature. We have to design the room, design the traveling vehicle, likewise your material. Okay, for that condition should be maintained in whole traveling, whole packaging, whole storage timing. If you are traveling a material from Tirunelveli to your Kashmir, means that will take a long time. That may be taken ship or train, but the box should be designed, or storing material should be designed for the particular raw material with they are maintaining low temperature. They need to maintain the low humidity, and that material should be protected from the light. Okay, after the packaging, this is the only thing. How after the collection we have to doing this process. Okay, once the package or stored material reach to the laboratory, some plant material. If you are obtaining a material for laboratory or any herbal industry, there are some small identification process identifying the plant. Till now we discussed how cultivate, collect, and process. Now we are going to discuss about the how to identifying the unknown plant. Okay, unknown plant. For the understanding, I am telling the unknown plant. Based on the morphology we can analyze, and histological study we can analyze. Okay, first based root type we can understand, we can find Google it. Okay, once you pick one plant of root. Okay, this is taproot or fibrous root we have to find. Normally, grasses are having a fibrous root, but some another other food crops are dicots. Dicots are having the taproot. Okay, more dicot having a taproot, because once you pick up the plant, you can identify the plant based on the root, which is dicot or monocot. This is the basic thing. After identification of the dicot monocot, we are need to go with the system, whether it is complicated or thick vein or a thin vein. Okay, if it is a monocot, it's a very fine lot of branches are there. They are fairly shallow. And if it is a dicot, taproot system is there. Taproot with a thick main root and fine lateral roots are there. Some adventurous roots are there, but this adventurous roots kind of materials, they are they are produced during the additional plant development. Okay, based on the root morphology, we are identifying some plants. Okay, how we can identify the type of the root that I mentioned: taproot, fibrous root, adventitious root, and size, the height, tuberous or canonical or cylindrical shape. Identify color of root, cracks, any cracks in the root, wrinkles, everything. Then fractures and textures are helps to identifying the plant based on the root. And transversation, some transversations also available in the particular roots. Based on that, we can identify which is help. Okay, and the anatomy of root we can identify in the plant, which may be the dicot or monocot. We can identifying based on the anatomy of the root. Okay, before ending with the, apart from other than the botany students or any some biological students, they are studied it in 11th 12th standard. The first one is epidermis and exodermis, internal layer, then endodermis. This epidermis is external, exo is next layer, it's a small layer, endo is the inner. Okay, endodermis having two portions on that's phylum, it's a central, and then passage cells are there and the surrounding cells. Okay, this is helpful for the identification of histology of the layer identification. One is cracks, that is phylum, and is cracked cambium. Cracked cambium is phylogens, that's inner layer. You can see this outer bark, inner bark, then inner layer, vascular cambium, pith, sapwood, and heart. Okay, based on this identification, we are going to the microscopical image or macroscopical image. If you are cut on the stem of a tree, you can identifying the cut on the stem or branches of the tree. You can easily identify whether it is dicot or monocot. If it is a dicot, you have the inner, the tuber cells are there. It's the fibrous cells are present in the inside the sessions. Okay, this diameter increase the secondary growth that producing the wood parks. That's this condition is it's indicating it's growing by day. The secondary growth is the monocot, and another hand have a loss of ability of secondary growth. Okay, that is do not produce the wood. Dicot can able to produce the they have a secondary growth, so they, but monocot won't producing they won't have a secondary growth, so it won't produce wood. So this having the monocot only have the vascular branches and ground tissues. But in dicot, we have a xylem, phloem, everything. Epidermis layer, vascular, the fiber cell. Okay, this is another explanation for the monocot dicot. In a dicot, we have the some vascular bundle system, ground system. Here I am explaining that. This is the difference between the dicot and monocot system. Here you can see the primary tissues which are present in the whenever you are starting the macrophagical and histopathological study, we have to understand the image, understand the cross-cut image or stained image. Then only you can understand whether it is monocot or dicot. Okay, for example, you can see this would like the system here monocot which having the only vascular bundles. So and their leaves are parallel veined leaves based on the leaf shape, leaf vein direction, seed condition. We can easily identify whether it is monocot or dicot. Here you can see the seed with the one cotyledon. Here you can see two cotyledons. Two cotyledons there. And the flowers are having a 4s, 5, maybe 4s, 5s. Here the flowers are 3s. The dicot plants are net veined system. No, they don't have a parallel system. This is another animation which helps to understand whether it is monocot, dicot. Okay, we can plant with their rhizome. This rhizome is nothing but they are ginger or ginger like plants material. The rhizomes does not look like quite similar or to stem. It's look having some different morphological character. Now, based on that, we can identifying the leaf. Based on the leaf, we can identify the nature plant material. Okay, and we can identify the seed based on the seed dissection. We can identify whether it is a monocot, dicot. The seed basically having the embryo, endosperm, and seed coat. So based on the embryo is helps to understand whether it is dicot, monocot. Here dicotyledons is there. Here cotyledons are present over in this image. You can see the cotyledons of the cross section, endosperm, seed coat, and cotyledons area is there. Just understanding of monocot, dicot with the pictures. I have included some more pictures are here. This is for your understanding. Here you can see flowers are three triples, three parts, and here we can see 4 and 5 petals. Here you can see the veins are net pattern. Here the leaves are in a parallel pattern, monocotyledons. This some examples. Okay, after collecting the plant leaf shape, you want to Google it. Okay, you have some unknown plant in your hand, have to Google it. You have to find out the plant name means you can take the plant. Okay, it having the for example, I am taken this plant the plant veining shape. First, I have to mention whether it is parallel veined or pinnated vein, or it may be the net vein. So I mentioned that vein, parallel veined shape, linear shape or ovulated shape, or any star shape, or pinnately lobed shape, or reniform, anything. You have to mention parallel veined linear shape, arrangement of simple arrangement, or palmately compound, or pinnately compound, or bipinnately. Bipinnately means that pinnated is arranged in a pinnated mode. So bipinnately compound leaf. So parallel veined linear shape, pinnately compound Margin means arrangement of leaves. It's a marginally arranged, or arrangement is alternate arrangement or opposite arrangement. So if you are searching like this, you can easily found the plant or the plant name. This is the way to identify, way to found the name. Okay, here I mentioned I mentioned the dissection process, right? That we have to dissect a plant and we have to stain the plant tissue and we have to view it under microscopical. After in under microscopical view, you can find in this process we have dehydration, clearing, and embedding. I include mentioning this website in the description, and also I'm mentioning in the Google Classroom. You can easily go to the website and study that protocol. So this is all about this understanding of how can we identifying the plant with the morphology or histology. Tomorrow we will discuss about some plant morphology, plant chemical studies. I welcome you all to day 3 classes. Thank you for your session.